Okay, we're going to go ahead and get into the conversation of equations. So yeah, you guys have already done equations. You've done equations for a very long time. And in fact, when you guys were in first grade, it was modeled kind of like this, where you're going, hey, if you have a number and you add 2 to it to equal 7, what is that number going to be? You guys have done that, again, since first grade, second grade, third grade. It's been modeled this way, where you say, hey, you have a certain amount of apples, and then you ate 4 apples and now only have 5. So how many apples did you start with? You have done that process, that concept, since you were little. So instead of it being a blank box, we now throw in a variable. So instead of the blank box plus 2 is equal to 7, we now write that it's x plus 2 is equal to 7. And when you're working a problem out like that, you use what's called inverse operations. Inverse operations to be able to solve. So for our inverse operations, we've got addition and subtraction, our inverses. And then we've got multiplication and division, our inverses. And what inverses means is opposite operations. So for example, in this problem, it says x plus 2 is equal to 7, but I need to know what x is going to be equal to. So I'm going to have to do the opposite of addition. And what was the opposite of addition? Subtraction. So instead of adding 2, I'm going to write down that I'm subtracting 2. But this equal sign kind of splits your equation up into 2 halves, and you want to keep them balanced. So whatever you do to one side of the equation, you have to do it to the other. So if I'm subtracting 2 to get rid of the 2 here, then I'm subtracting 2 on the other side as well. And that's where I can cancel out these 2's, and I'm left with my variable by itself, and I find out that x is equal to 5. So again, addition and subtraction, sit down. Addition and subtraction are considered to be inverse operations. Addition and subtractions are our inverse operations. So that means that if I start off with a number, a random number, let's say I start off with 8, and I add 5, and then I subtract 5, it's as if I never did anything to it at all. They cancel each other out, and I'm still left with the 8. Let me say that again. If I start with some random number and I add 5, but then I subtract 5. So 8 plus 5 is 13. 13 minus 5 is 8. So adding 5 and then subtracting 5, they have a canceling effect on each other. It's as if they never happened. So addition and subtraction of the exact same value will cancel each other out. Same thing for multiplication and division. Multiplication and division also have an inverse effect, an opposite effect on each other. So if I were to start with, again, let's say I start with the number 8, and I decide that I'm going to go ahead, it froze, hold on. I'm going to go ahead and I'm going to multiply by 2, and then I'm going to divide by 2. So 8 times 2 is 16, and 16 divided by 2 is 8. So multiplying by the 2 and then dividing by the 2, they kind of cancel each other out. And you're just left with the number that you started with, the 8. So they have inverse effects. So your goal when you are trying to go ahead and what we call isolate a variable, we're trying to get a variable or the letter by itself. We don't want any addition signs or subtraction signs or multiplication or division involving the variable. We want it to say x equals, y equals, r equals. We want it to be a letter equals, and it's just a number. That's what isolating the variable means. So starting up here for problem number 1, we've got 5x is equal to 30. 5x is equal to 30. when they are side by side like this, 5x, what operation is that right now? 5x is what kind of operation, Emmy? Multiplication. Thank you. So because this is multiplication, we want to do the inverse. What is the inverse? Division. So we're going to do the inverse. Inverse is division. The inverse is division. So that means instead of multiplying by 5, we are going to divide by 5 on both sides. We are going to divide by 5 on both sides. So I'm going to divide by 5 here. Remember, a fraction bar is a division sign. And I'm going to divide by 5 on the other side. So what do we get? If we do 5 divided by 5, what does that become? What's 5 divided by 5? 1. 1. 5 divided by 5 is just a 1. So I'm going to cross through it. It's going to equal a 1. Do I have to write the 1? No, you do not have to write the 1. So I can just put X. I know, it's going to freeze. They said they fixed it, but apparently they didn't. Okay. Now we're going to do 30 divided by 5. What is 30 divided by 5? 6. So we're going to get that X is equal to 6. And then we can check it. We can plug this back in and go, okay, hey, 5 times 6 equals 30. I got the right answer. Okay, let's take a look at problem number 2. We have X minus 8 is equal to negative 15. X minus 8 is equal to negative 15. Who can tell me what is the inverse operation? What is the opposite operation? Addition. The inverse is addition. Our inverse operation in this case is addition. So we are going to add 8 to both sides. We are going to add 8 to both sides. So I'm going to do a plus 8 here and a plus 8 on the right side of my equal sign. So when we say both sides means that equal sign. If you need to draw an imaginary wall, I've had kids do that in the past. They like to draw a little imaginary wall right where the equal sign is so that they know that you're going to do it on the left side of the wall and you're going to do it on the right side of the wall. Perfectly fine to do that. So this minus 8 and this plus 8, notice they look like 0 pairs. And 0 pairs cancels each other out. I can X it out. And I'm left with just my X. Now I need to do negative 15 plus 8. Negative 15 plus 8. Go ahead and do that right now on your calculator. What is negative 15 plus 8, Fiona? Negative 7. Very good. Negative 15 plus 8 is going to equal negative 7. And there's our solution. And we can plug that in. We could write negative 7 minus 8. And if we do negative 7 minus 8, it gives us negative 15. So we are identifying what the inverse operation is. And what are we doing with that operation? Not just that it's division, but what are we dividing both sides by? What are we multiplying both sides by? What are we adding or subtracting both sides by? Okay, let's go on to the next page. Turn it over to the back. Take a look at problem number 3. We have x over 4 equals 1/2. X over 4 equals 1 over 2. What operation is x over 4? Division, right? X over 4 is just a division problem. So what is the inverse operation to our division? Multiplication. Okay. The inverse operation is just going to be multiplication. All right, it's freezing up again, so I'm trying to get it to unfreeze. Okay, so the inverse is multiplication. The inverse operation is multiplication. So what are we going to multiply both sides by? What are we currently dividing by? We're dividing by 4, right? So instead of dividing by 4, we're going to multiply both sides by 4. Multiply by 4 on both sides. We want to multiply by 4 on both sides. So if I multiply by 4 here, those 4s are going to simplify out and my x will be by itself. And then I'm going to multiply by 4 here. I'm going to take 1 over 2 and I'm going to multiply it by 4. 1 over 2 times 4. Jeremy, what do we get? Did you have a question? No? Okay. Who can tell me what is 1 over 2 times 4? Daniel? 2. 1 over 2 times 4 is just going to come out to 2, a positive 2. Okay, problem number 4. M minus 8 is equal to negative 3. M minus 8 is equal to negative 3. What inverse operation are we going to do here? Marianne, what's the inverse operation here? The opposite operation. What operation are we doing right now? Subtraction. And what's the opposite of subtraction, Marianne? Addition. Okay. So the inverse is addition. So we are going to add 8 to both sides. We're going to add 8 to both sides. So we're going to do a plus 8 on the left side of my equal sign. So remember, if you need to draw a little wall, you can. We're going to add 8 to the right side of my equal sign. Okay, a minus 8 and a plus 8 are like 0 pairs. They cancel each other out. And M is now isolated. It's all by itself. And what is negative 3 plus 8, Ian? 5. Okay, what I want you guys to do is problems 5 through, let's just do 5 through 8 for right now. Don't do the other ones yet. Just do 5 through 8 for right now. And I'm going to randomly call on students. And if you have the correct answer, you'll get a piece of candy. Don't raise your hand, though. I will randomly call on you. Who's sitting at table number 8? Table number 8, you get to answer first. Who's that? Vincent? What did you get for number 5? X equals 1.7, correct. So I'll let you get a piece of candy in just a little bit. Let's go over this. This was an addition problem. Our inverse operation to addition is to subtract. So the inverse is subtraction. You should have that written down. So that means you are going to subtract. You're going to subtract 7.2 on both sides. So when you subtract 7.2, they're going to cancel out here. Subtract 7.2 on the right side, and you're going to get x is equal to 1.7. Number 6. That goes to person number 26, who's sitting at desk 26. Is that you, Abdullah? What'd you get? 6. Nope, not quite. Not quite. Let's go for somebody else. Huh? I understand that's still not correct. Person 24, who's sitting at desk 24. What did you get for number 6? 12 is the correct answer. Well, that's what I'm going to go over. All right, so Vincent and Chris, you guys are going to be able to get a piece of candy in just a little bit. All right, so for here, right now, it says 3/4 x. 3/4 x. That's multiplication currently. The inverse operation would be to divide. So you're going to divide both sides. So the inverse is division. The inverse is division. You are going to divide by 3/4 on both sides. So you're going to take 3/4 and divide it by 3/4. That'll cancel it out. Then you're going to take 9 and you're going to divide it by 3/4. So if you do 9 divided by 3/4, that's also the same thing as saying 9 times 4 over 3. And that's going to come out to 12. Okay, remember when a number, whether it's a whole number or an integer, a decimal, a fraction, if it's in front of the variable, that currently showcases multiplication. Your inverse operation will always be division. Okay, problem number 7, that's going to go to person 22. That would be you, Ian. You're desk 22. What did you get for problem number 7? R is equal to 22. Oh, no, you were right the first time. 22. You're right the first time. Positive 22. Okay, so our inverse operation in this case, our inverse operation is going to be multiplication. Right now we are dividing by -2. So the opposite, the inverse, is going to be multiplication. The inverse is multiplication. So you are going to multiply by -2 on both sides. You're going to multiply by -2 onto both sides. So you're going to take r over -2 and multiply it by -2. That'll cancel it out here. Then you're going to take -11 and you're going to multiply it by -2. And that's going to come out to a positive 22. So r is equal to a positive 22 for this one. Okay, problem number 8. That goes to person 28. Okay, Anna, what did you get? Not quite. It's not -5. Let's go with, oh, I already called on that person. How about person 2? Hey, it's you. Huh? -11. It's going to be a -11. Right now, what operation do we see? What operation is this, guys? Subtraction. The operation is currently subtraction. What is the inverse of subtraction? Addition. Our inverse is addition. So we are going to add -3. Right now we are subtracting by a -3. So the inverse is to add a -3 to both sides. You do the inverse of the operation, not of the number. You do the inverse of the operation, not of the number. So you are adding a -3 to both sides. Okay, -8 plus -3 comes out to a -11. Okay, so that's going to be, who's that? That's Daniel, Ian, Christopher, and Vincent, right? Okay, we still have 3 more problems to try. Go over to the last page, 9 through 11. Go ahead and try those. You'll get an opportunity to try for candy then too. Those 4 people, come on up and get yours. All right, number 9, that's going to go to, let's see, person 15. Who sits at desk 15? All right, Marianne, what did you get for problem number 9? 45, very good. Okay, so for a problem like this one, again, this was multiplication. It's 4/9 times x is equal to 20. So instead, what you're going to do is you are going to divide by 4/9 on both sides. You are going to divide by 4/9 onto both sides. So you're going to take 4/9 and divide it by 4/9. That'll cancel out, and you'll be left with just x. Then you're going to take 20, and you're going to divide it by 4/9. 20 divided by 4/9 is the same thing as saying 20 times 9 over 4, which comes out to 45. So x is going to be equal to 45. Okay, problem number 10. Problem number 10 is going to go to person 27. Who's 27? Ezra, what did you get for problem 10? 10 is correct. For this one, shh, quiet. You are currently dividing by -4, so this time you're going to go ahead and multiply both sides by -4. So you're going to multiply the left side by -4, that gets x by itself, and then you're going to multiply -2.5 times -4. -2.5 times -4 comes out to a +10. Okay, and then the last problem, number 11, x plus 9 is equal to 6.2. That's going to go to person 10. That's you, Esther. Okay, then let's go to person 1. Okay, person, oh, already had that, person 7. -2.8. It wasn't again, he hasn't had one yet. Okay, you are going to subtract. You're going to subtract 9 from both sides. When you subtract 9, you're going to get x is equal to -2.8. All right, go on to Google Classroom. You have an IXL and a Delta Math. IXL and Delta Math that needs to be completed.